Hello friends, welcome to our channel. In this video, we are going to cover LangGraph for beginners. Those who are new to LangGraph may find this video very helpful because we are going to cover very basic. We will talk about the workflow that LangGraph support without even talking about the agent first, and then we are going to see a very simple chat example using LangGraph. So let us understand first how it is different from LangChain. So let's first see LangChain, how this is linear things work in LangChain. So if I write in here about LangChain. So basically, LangChain says that you can create a chain. You can create a chain. So they given a class LLM chain. Using this LLM chain, we can pass on a prompt as an argument, and then that it supports two arguments, prompt and LLM. So I'm just depicting this in a diagram. Okay. So to talk that this is a chain basically. So prompt can be fed to LLM basically, and then output of the LLM, basically response from the LLM, we can make use of the output parser. Okay. We have covered this output parser in detail in the last videos. Obviously, you can take a look of this particular flow in the last videos about LangChain. Okay, this representation is a chain. Okay, now LangChain says that you can create as many chains you want, and then you can also connect this chain together using different type of chains like sequential chain, transform chain, and a lot of other chains. Okay, so think of it this as a chain. Then it says that these chains can be interconnected with each other. Chain 1, chain 2, chain 3. Okay, so you can, for building this kind of chain, you can make use of sequential chain class. Okay, and there are other map reduce chain, transformer chain, etc, etc. Okay, it also supports a router chain as well, where you can take a decision and route to a different chain. But in this case, if you do the interaction, like, so mostly the states that developer has to take care, there is no centralized state management within the LangChain. Okay, so every chain has its own state. Okay, and we make use of that to make a decision to go to the another chain. Okay, so basically it is not very centralized. It's discrete basically in nature, and the control thing is little less. So we need to manage that control in our logic, if else conditions, a lot of other things we need to take care of self. Okay, so that is what it says, that linear agent flow in LangChain. So LangChain team created LangGraph and says that okay, we can actually create a complex workflow using LangGraph, and also multi-agent is totally a solution can completely be created using the LangGraph. Now let us see how this is different in case of LangGraph world. Okay, so if I say LangGraph, okay, so what is the component in case of LangGraph? So basic components like prompt, LLM, output parser still exist, or still we can use within LangGraph. But the idea is that LangGraph is totally graph modeling. Basically, like the graphs, we have nodes and edges. You might have learned about graphs in your course in BTech and all, right? So there are the important pillars of the LangGraph is basically a graph itself, okay? And the graph consists of nodes, edges, okay, which connects nodes together. There is another concept of edges basically in LangGraph, which is conditional edge. Conditional edge. And this graph is having a centralized state, like those who are coming from the world of like front end Redux and all. So this is a concept of state management, which is centralized across the front end application, which is state management, state basically. Similarly, there is a concept of state, which centralized state, which we can associate with the graph state. Okay, so initially when we create a graph in case of LangGraph, we first initialize the state. We first create the state is nothing but, think of it like a type. Okay, if declare a variable, that's it, it is a state. Okay, so that variable can be very simple enough, or it can be complex. It can be a key value, like it can be list, it can be string. Okay, so you just create that state, pass on to the graph, initialize the graph. Okay, so that way our canvas, that canvas is ready. Canvas is ready with the state. Canvas is ready with the state. Now you need to create the nodes, small nodes. Okay, so what these nodes are nothing but functions only. Okay, you define a function, you actually create this. These are nothing but compute functions, which responsibility is to take in the state as an input parameter and manipulate that state and return the slice of the state or the complete state. Okay, so we create the nodes which actually read the states. Okay, read the state and update the state basically. Similarly, every node. Okay, it's up to us if we want to change the, suppose you have key value pair 3 you say 3 key value within that a dictionary. Okay. Now this particular node is only updating key 1. This node, N2 node can update all 3 keys, N3 nodes can update the third key. Okay. It depends. So they read the state or they return. The important thing is that the function should return a state. This is mandatory. Okay. It's not mandatory to return the entire state, entire 3 key dictionary. They can return a single key, 2 key, 3 key, whatever, but they need to return a state. So this is some structured function, like the schema is more or less defined by LangGraph only. The logic is written by you only. So nodes are taking the state as an input and returning the slice or the complete state. Okay. Now suppose the nodes are ready. Okay. These nodes are ready. Now after that we need to create the edges. Okay. So edges are connections. Okay. Connection between the nodes. So we, in case of edges, we say that N1 can be connected to N2. Suppose these are N1, this is N2, this is N3. Okay. So in the edge case, we say that N1 is connected to N2, N2 is connected to N3, something like that. So this thing is actually created using the edges concept in LangGraph. So like this. So after that, this picture will look like this. Okay. The conditional edge is nothing but like a condition. Okay. It simply, again, a small function which returns the node as a string. Like what it does, conditional edge is taking a state as an input. Okay. And returns, taking a state as an input and returns a boolean string, basically, returns a string. The string is nothing but name of the node. Okay. So conditional has nothing but a small function which takes in the state, do some computation or conditional logic, and then return the name of the node. So suppose the conditional node, in case of N1, suppose we have a conditional node which like this condition. Okay. If the condition is true, for example, the state computation logic is like such that it met the condition, then it returns N3. Otherwise, this is end. Okay. Otherwise, nothing. Okay. Let's talk about further about the LangGraph. Okay. So what else we have in the LangGraph concept wise? We have command. We also have human in the loop concept, interrupt. Okay. This we will cover in the upcoming videos. Okay. And yeah, so that is other components of the LangGraph. So let's get on the VSCode and talk about coding within the LangGraph. Okay. So let me just show you the example, actual code by which we can create the graph in the VSCode. Okay. So we will first create a small graph using LangGraph, and this is what the smallest graph, like for example, every language has hello world concept. Similarly here, I'm going to show you the basic graph without even talking about the agents, AI, etc. So because LangGraph, although it's responsible for creating multi-agent flow, it came in the world because of creating AI solution, but still you can use the LangGraph independent of that as well. Like if you want to create a graph, your solution is more of like workflow and orchestration basically, then you can still use the LangGraph. Okay. So here in this diagram, you see we have start, we have end, and then in between we have add node, show node. Okay. So node are nothing but Python functions only, which take in the state as an argument and return the state or a slice of a state. Okay. Now the good thing is that LangGraph itself gives two nodes by default, which is start node and end node, and we can utilize that start node and end node to create the complete graph. Okay. So this is, we are going to build start and end, and then add. We are going to create an add function, show function, then create a nodes, create an edge, and then associate with each other and invoke it. So in this, I'm using both the examples I have in this source code. The link of this source code is present in the description section. You can simply download that code and run it in your local. For this particular source code, I'm using UV. So to read about UV, you can still watch a video on UV by our channel. So what is the setup here? We simply create a simple Python project using UV init, and then we make use of this Python function and use UV run command to run the program. Okay. Now in this case, I'm going to show you two cases. Basically, I'm also having notebook approach here, IPynb file, as well as a normal py function. Those who are very familiar with notebook approach, they can simply run this program, okay, and otherwise they can go here, normal function, they can still run the normal function and use uv run command. So I'm going to show you the notebook function just to here. Okay. So what we are doing to make it working in the VSCode, the notebook thing using UV, what you need to do, you need to just use the UV command to support the notebook function. So what we have installed here, if you look into this, we have installed, I think not explicitly anything is needed to be installed. Yeah, sorry. So we have installed this IPY kernel as a dev dependency using UV. And then finally, we simply writing the pynb notebook file here, and make sure you follow this statement exclamation UV before writing pip install. So in this approach, it does not update any dependencies within this py.project.toml file, and you can still run the notebook within your VS Code. Okay. So to run this program, simply we just install, we just import state graph itself, right? The graph itself to initialize it. Start and end, as I talked about it, they are the nodes which is supplied by LangGraph itself. And then we are simply using IPython display to show you the graph, actually the graph, the diagram way. Okay, it is not mandatory. Okay, this is for this tutorial purpose only. Okay, so if you look into this program, very simple program, we first create the state. Okay, now the thing is that it is recommended to create the state as a typed dictionary, but you can still create a list or a string. Okay, but it is always recommended to create typed dictionary or using the base model using Pydantic, those who are familiar with Pydantic. Okay, so it always help like to validate the state. So first we create the state. Okay, state is nothing but, again I talked about key value pair dictionary. Here in this example I am showing you the add function which takes two input, two numbers, number 1 and number 2, and the output result. Okay, now here we are initializing the state, simply passing the state. This is not predefined, so this name we can give anything. Okay, and this is passed as argument to the state graph, and we are initializing this graph first. Okay, now we are creating this particular function. Okay, now we simply say this is a simple add function, and since I talked about it, node is always going to take the state as an argument and do some computation and return the state. Okay, here also it takes the state as an argument. Okay, and do some computation, basically add the two numbers and return the state. Okay, return the state means, as this one is returning only result, which is not the entire state, which is a slice of a state. Okay, this is what I talked about. It should return a state. It could be a one key out of 100 keys from a state or entire state. Okay, so here it returns only the result key value pair. Okay, after that I am having this show function. Okay, and show function responsibility is to print the result. So it's simply taking the state, print the result. I'm not returning anything here because it literally we do not want the state to manipulate here, because it is just an absorbing function. It simply takes in the input, print it. Okay, now these are the important functions. To add a node into the graph, we use graph.addNode function, and this is a string what name we want to give to the node, n1, n2, n3, whatever. Okay, it's up to you. The function name is add. You can also give the node name as sum. Okay, it's up to you. And then the name of the function. Okay, similarly we are associating the show function, and then we are going to use the add edge function to create the edges. As I told, start and end nodes are provided by LangGraph only. So think of it like we are doing the start, we are connecting the start node with the add node, and after, as you see in this diagram, we are connecting the start node with the add node using the add edge, and then we are connecting add to show, and then we are connecting show to end using add edge approach. Okay, now then ultimately my graph is ready with node, edge as well as state, and this function we have to call graph.compile. Okay, let me just zoom in a bit. I hope should be a problem for you. So yeah, so here after creating the graph, I'm using graph.compile function to compile the graph, and ultimately there is a function, invoke function. So I'm invoking the graph, so with the input state. So this is important. So whenever you want to invoke the graph, you have to invoke it with the state. Again, here you can give the slice or the entire state to invoke the graph. So as soon as I am passing in the number 1 and number 2, okay, because obviously to invoke a function we need to give some input to the function, then the function compute the result. Okay, so here I am giving that input to the function, and as soon as I am doing the invoke, the LangGraph will take it as an input, invoke that subsequent node, compute node, and that compute node return the result. That result will fed to the another node, and another node print the result and output. Okay, so just for saving the time, I am showing you the output here only. So after playing this all the notebook code section, finally the output will be this number 1, number 2, and this result is 3. Okay, so this is how the basic of LangGraph, basically to create a small graph. Although by looking into this example, you say that I normally was doing the add function, showing the print function, etc. What value it is adding. Okay, so here we are seeing everything in terms of workflow wise, like everything in terms of nodes, in terms of edges. So it is helpful in creating the complex graph, complex workflow, so that you can easily visualize what all things are happening here. You can make use of the graph builder, like LangGraph also gives some graph builder as well, to drag and drop and create the nodes and edges all together, and then complex functionality can be created. Okay, similarly, let me walk you to the another example, okay, which is conditional edge example. Here there is no conditional edge example. Let me take you to the another example, which is a very banking application example. For example, we are creating a withdrawal application, okay, amount withdrawal application, which is here in this case also I'm not using any LLM, etc. This is a very simple graph where we are saying that, okay, we have list of accounts with amounts with us already, and user is interested in withdrawing amount from his account. Okay, so where the user can supply the account ID and the amount he wants to withdraw, that's it. So after we are receiving the input from the user, we are using the validate as a conditional edge, basically, and we will validate it. If the validation is succeed, means the account is available and the amount that he wants to withdraw is present within the bank account, then only the deduction will happen, right? So in this case also we are validating it. If the validation is failed, we are going to the failure node and then ending the overall flow. Otherwise, we are withdrawing the amount, we are printing the balance, and then ending the flow. Okay, let us quickly see the code. Okay, it looks like very big code, but not that. Here also we are simply using the import statements. Just for saving the time, I'm quickly going to run through. Here the thing is that I'm creating a state. We are saying that, okay, we have a list of accounts with us already, and then I'm creating a user input as a key to collect the user input, and then it represents the transaction, whether the transaction is failed or not, and the code. So again, we are initializing the state graph, the LangGraph. Okay, and then we are declaring the function for each of the node, and this get account is simply taking the user input. Okay, and then finding basis on the user input, we are finding out the account of a user. Okay, similarly, we have get user input as a node. We are creating a function to collect the input from the user. Okay, using the input function. Okay, so here the thing is that those who are reading the interrupt and why do we need interrupt, so make sure that they are different. We can still take the input from the user without even using the interrupt function by the LangGraph. It has its own use case. We will cover it up in the upcoming video. So then we have a validate node. This validate one is nothing but conditional edge. Okay, so what it does, basically it takes in the user input. It checks whether the account is available or not. If not, we are failing it. Otherwise, this is not conditional node. This is normal node. It's doing the validation. Okay, and after validation is updating the state, and then this is a conditional node. This condition, it simply takes whether the failure happened. Yes, then go to the failure node. Otherwise, go to the withdraw node. Okay, so as I told, the conditional edge always returns the string. So here I am passing it using the literal type, and where the withdrawal and failure string is present. Okay, basically the string should be returned. Okay, so this is all about this particular example. If I take a look into the nodes, we are adding the node get user input, validate node, withdraw node, print balance node, and failure node, as I told earlier. And then we are doing the edging. Start, as I told, already available. Start to get user input to validate, and then we are adding the conditional edge. Okay, so make sure that this is a conditional edge. This one is the node from which this is the starting node. If you look into this diagram, this is a node then this is the conditional edge. Okay, so validate is actually connected to a function. Okay, so if you see this, in this particular point there is a function, condition function, which decides where to go. Okay, it is not shown in this graph. Basically when we print this graph, it is not showing me the conditional edge. Okay, but condition is a function which returns whether to go to the withdraw node or the failure node. This is a function. Okay, this is a node, this is a function, and this function decides where to go. And finally other edges we have created within this graph. Okay, and after that we are doing the compilation, and then finally we are doing this execution. So when we do this execution, say if you mention, this is what you see. Initial state, we are declaring all the accounts with the amount numbers, and then we are passing this initial state to invoke the graph. As soon as we invoke the graph, it asks input from the user, validate that input, and then do the withdrawal, and this is the final output. So here I'm passing the input as A1 and withdrawal amount as 100. It will find A1, withdrawal amount 100, and then finally it executes it. Okay, because the initial balance we are giving 200, the output is 100 ultimately. Okay, so this is the basic example of using LangGraph, how we can utilize LangGraph in creating the workflow, etc. Okay. Those who are interested in knowing how we can use LangGraph in doing the simple bot application like talking to the LLM, this is the simplest of the example I have created to demonstrate it. So here we are doing everything same, nothing new. This is very simple. We are doing start and then chatting with the LLM and then doing the end. That's it. Okay. So in this flow, the only thing difference is messages as a key, and then this is the data type we are using to interact with the LLM. Okay, messages and the annotated list add messages. Here instead of declaring it as list only, we are using annotated type, where we are passing add messages function as a reducer function, which is provided by LangGraph itself. What it does basically, whenever we return a function from a LangGraph node, it returns the slice or a complete state. The default behavior is overriding the state. But if we introduce this reducer function, the overriding, the default behavior of a function returning a state is a overriding. Basically, if the key value is 1 and a function is returning that key value as 2, the 1 will get overridden by 2. But in case if you want to append or you want to do something else, so you can introduce a reducer function and then the behavior will be different. Okay, in this case we want to add all the messages that is responded back from the LLM into a state. Then we introduce a add messages reducer function, which is provided by the LangGraph itself. Okay. And then what we do, normal function, chatbot function, llm.invoke, that we already have been seeing in the LangChain examples, which is just an invocation of the LLM to get the output. So let us see quickly. So what we are doing here, we are showing invoke, and this is what we have seen in the LangChain example as well. Role as user, content, hey, can you suggest me one book on AI? Okay, what happens immediately? It will invoke this chatbot node, and this chatbot node is invoked means the function gets invoked. The state will receive this role and content as an input, and simply we are invoking this llm.invoke, collect the response as AI message, and then feeding it to the messages key and returning this as a state. Basically, we are keep on storing the response from the LLM and then returning back. Ultimately, we are printing that message using the -1 because we want to print the last message from the interaction, from the conversation. So that is how it works. Ultimately, let me run this program quickly. UV run simple chat with LLM. Okay. Hit enter and it will suggest me the book on AI. This is the book it suggested from the AI. Okay, so that's it for this video. I hope you understand the concept of LangGraph, understand the concept of the components of the LangGraph and how they can be used in order to create the workflow. In the upcoming video, we are going to see how we can build LangGraph AI agent using this workflow, and we'll more focused on tool calling and how we can build multi-agent patterns using LangGraph. Thank you so much for watching for this video, and stay connected for upcoming videos. Subscribe to this channel if you are new, and goodbye till now. Bye.